topic A2 is the factoring topic. So what I want to do is quickly go through a solution, quote unquote, to these two problems and ask you to find where it's wrong. So let's do problem 3 first. Problem 3 asks us to factor this expression completely. Z to the fourth minus 11z to the third plus 10z squared. Here's my solution. I write that as z squared minus 11z plus 10, and then I factor. So which of these lines is not correct? Which step was not the step that I wanted, Clay?
The last one.
This step right here? What's wrong with it?
Well, that's right, but you need this and the second.
Right. So I would think it's the first line. So if I wanted to fix this problem, how would I do that? What did I need to do here that we didn't do on the first version? Yeah.
You can make the second equation parentheses and outside.
Yeah. We divided away a z squared when what we wanted to do was factor it out. And so that z squared still has to be there as one of the factors in my final answer. Right? So what I've tried to do with these wrong solutions is I tried to hit on some of the common just the little common errors that crop up in doing this work. So yeah, definitely keep that z squared. All right, here's question 2. It asks us to expand out this expression, 2t minus 3, the quantity cubed. And here's the kind of solution that I tend to see a lot. Okay. So what did this person do in this solution?
They distributed the cube.
They distributed the cube. Okay, do we like that?
No.
I've already given away that each one of these solutions is wrong. So what should I have done instead?
Expanded so it's 3 sets of 2t minus 3.
Yeah. Anytime you have an exponent on the outside with addition or subtraction on the inside of a quantity, always raise that red flag, right? And always turn those problems into multiplication problems. Write them out as that product of 3 serial factors, 2t minus 3 times 2t minus 3 times 2t minus 3. Because at the end of the day, how many products are we going to have to do to expand that all out? If I have 2 terms times 2 terms times 2 terms, I'm going to have 2 times 2 times 2, 8 different products to do, right? Each one of these multiplied by each one of those multiplied by each one of those. Right? And so this 8t cubed and minus 27, those are going to be a part of my final answer, right? But I'm going to have 6 other terms in here as well, right? And so when you do all that arithmetic, somebody that got a final answer to this, can you read it off for me? 8t cubed, and then what came after that?
Minus 36.
How many?
Minus 36. You go.
We'll take turns.
Minus 36t squared.
Okay.
Plus 54t minus 27.
54t. Yeah, right. So those 2 terms aren't wrong. That's just not a complete picture. Once we get everything multiplied out, we need all 4 of those terms. So yeah, never distribute a power across addition or subtraction. Okay. Let's move on from A2 to A3. This is our lines, equations for lines topic. Oh, no, wait, sorry. Yeah, let's go to that one next. So again, this is an important topic very quickly in our course. So here's some work. Suppose I take this slope, and I'm like, all right, so I want to get 1 minus negative 4, negative 2 minus negative 7. I divide it out, I get 1. And then once I know my slope, I can kind of plug in my slope-intercept format and get a final answer. So there might be more than one thing that's amiss here. What's one thing that definitely doesn't seem right?
Well, it's supposed to be point slope.
Right, so the first thing that you might notice is the problem here is specifically requesting for the point slope form of the equation. And so we have to figure out what that means. Where did my pencil go? What the question wanted was for us to use the point slope template for our linear equation. What does a point slope template look like?
Y
Equals?
m parentheses x minus x1.
Yeah, as long as we're consistent, we can either put the y1 before the y or the x1 before the x, as long as we do both or neither, right? Right, so there's an example of a point slope template. You may be familiar with this in slightly different looking formats, but they're all the same, right? I could put the y1 and x1 second in those differences. I could write them as y0 and x0. Right? It doesn't matter what we call them. It matters the roles that they play in this equation. What role does m play?
Slope.
M is supposed to be my slope. So probably I would put my slope right here. What about the x0 and y0, or x1 and y1? What are those supposed to be?
Y0, 1.
Right, so I'm supposed to, so what should I fill in there? Like, what should I put in for x0?
-2. I mean, 1.
1. So the x-coordinate of this point, so I'll put a 1 right there. And then what would I put over here for y? 0. -2. Right? But wait, why did I choose that point? What if I chose the other one? What if I put a -4 in for this x coordinate over here and a -7 in there for the y coordinate?
It would have been y plus 7 equals 1x. I mean, 1x plus 4.
Right, so if I make a different choice, I get a different answer. How's that possible? Let's check, by the way. So the other version would be y plus 7 equals 1 times x plus 4, right? Those look like different things. Well, why is that okay?
It's all the same line.
It's all the same line. Let's solve the second equation for y. Y equals x plus 4 plus 7. It's x plus 11, right? If I solve the first equation for y, oh wait, no, sorry, it's minus 7, so minus 3. If I solve this first equation for y equals x minus 1 minus 2, it's y equals x minus 3. Right? So they describe the same line, so it doesn't matter which of those 2 points that you choose. I think I did something else wrong here, though. Or did I? Did everybody get 1 for the slope of this line?
Yeah.
I did? I still claim that I did something wrong. This is a place to be very careful in your own work. Look what happened when I computed the slope. I did 1 minus -4 up here, -2 minus -7 down there. Why is that not correct?
Oh, it should be the other way.
It should be the other way around. Why?
It's y2 minus 1.
Yeah, we want the y's on the top. The y's are the rise, and slope is rise over run, right? So, right, that is such a common slip in computing a slope that I had to include it in this problem, right? And you wouldn't have noticed because the answer was still 1 because it's its own reciprocal, right? So it didn't matter to my answer, but it mattered to my work, so be super careful with that. Maybe we won't talk about this example. But to find the slope of this line, what did you have to do? Number 9?
You had to take the 5x, put it on the other side of
Yeah.
the equation, and then divide by -8.
Get the y by itself, right? So what mistake did I make here when I found the solve for that y? Yeah.
You didn't divide the 2 by -8?
I didn't divide the whole right-hand side by -8. I only divided this one term by -8. Yeah, that's no good. So right, divide both those terms by -8. Okay, promise, last bit. This one will go a little bit faster, I think. So here is the literal equations. Solve this one for r. I think I talked to every group that did this, so you probably have this answer off the top of your head. If I solve this for for r, and I end up getting this expression, what have I forgotten?
The plus or minus.
A plus or a minus. Why? Why was I harping on you about that? What happens if I forget that plus or minus?
It always comes out positive.
Right, this value always comes out positive, when in the original equation, there's nothing forcing r to always be positive. It could be negative as well. By the way, another way to keep this last bit straight is anytime you take the square root of something squared, it doesn't just cancel. It becomes the absolute value. Absolute value of r is equal to 3 square root of 3b.
You multiply by 3 already.
Yeah. And then when the absolute value goes away, that's where the plus or minus comes from. Okay. And then here's this literal equation. We're trying to get h by itself. So here on the first line, I'm getting rid of my pi's, and then I'm going to subtract the r squared, then I'm going to divide by 2r. What did I screw up there? Yeah.
You lost the pie.
I lost the pi, which is definitely something. It's the same mistake, by the way, that we made when we were incorrectly factoring this z squared here, right? It's just it's kind of showing up in a different context. So if I lost my pi, where should it have gone here? Because I claim that it's okay to cross out the pi's, but what am I really doing when I cross out the pi's from those terms? Yeah, I'm factoring it out, and then I'm dividing the pi's away. But if I divide the right-hand side by pi, I have to divide the left-hand side by pi. So the expeditious way to fix this is just to make this left-hand side over here s over pi. Right? That's fine. Then I really have divided both sides by pi, and I'm okay. and then I'll just carry my s over pi all the way through here. Right? Then I have kind of a messy expression for my final answer, but at least it's correct. If I wanted to make this a simple fraction, I would just multiply the top and the bottom of it by pi and get s minus pi r squared over 2 pi r, which I think is what you would have gotten for this final answer.